Hello guys, Prof here. Welcome to another episode of our Python for Data Science tutorial series. Now in this episode I'm going to talk about variables and objects in Python. In Python, everything is pretty much an object, unlike C++ and C++, which have primitive types like the int. Python, every variable you create actually points to an object. Okay, when we talk of object, is an instance of a class, something you would understand much when we start with the concept of object-oriented programming. Variables are references to these objects. So when I create a variable in respect, I'm just creating a label to an object, which is actually a value sitting somewhere in memory. All right, so let's launch our Python in an interactive mode and take a look at these things. Okay, so a variable is created by simply using it. All you need is a name which serves as a label for the object. Okay, so for instance, if I type age equals to 23, for instance, the name is age and the value is 23. So the 23 is the object and this age is the variable, a name that I'm associating with the object, so that anytime I type age, Python will return the value or the object that is associated with that name. So take it as a group of students in a class. Each student is assigned a name. So when your name is mentioned, you respond to the caller. Okay. As a matter of fact, when you create objects, they are sitting somewhere in the memory of your computer. And the way computer tracks memory spaces or addresses is by numbers. Okay, and trust me, it'll be so inconvenient for you to be keeping these memory addresses in your head. That's too much work. So in a simple analogy, take it as the right way of identifying locations on Earth. Okay, it's actually by their GPS coordinate. So you have the latitude and the longitude values, then you can locate any place. However, just imagine going about, or you are traveling and you have to be remembering all these GPS coordinates, all these long values and stuff. That will make that seems to me like so much work. However, human beings, we solve these problems in a smart way by assigning simple to remember names to these places. So as you are traveling, you don't have to, you need not have a clue about what the GPS location is. All you have to know is the name everybody calls it. So if I should ask you the question, what is the GPS location of your actual location right now? Chances are that you would have to take your Google map and find it out. However, if I ask you right now, where are you? You would mention the name of what? That area. So by assigning names to areas, something like Accra, Kejetia, Ayediase, Kumasi, it gives us a simple way of identifying places without any hassle. Now, similarly, when you create an object, it stays somewhere in the computer's memory. It will be a lot of work having to keep track of these memory addresses. So by using variables, by using very nice variable names, you kind of assign an easy to remember label to these memory spaces so that it becomes easy to reference them. Now, in C++ and Java, to create a variable, you have to specify what we call the data type, which tells the computer the amount of space to allocate for it and also the kind of operations that can be performed on it. For instance, if I create a variable of type integer, then I can multiply it by another number, I can divide, I can perform the basic arithmetic operations on it. However, if I store something like my name, I can't divide it, I can't subtract it. It doesn't make sense doing such a thing. Okay, so by the data type allows the computer to know how much space it should leave for it and also the kind of operations that can be performed on the object. Okay, so all languages that you have to explicitly state the data type of the variable, we say that they have static typing. However, in Python, you don't have to explicitly declare the data type. Python has its own way of inferring the data type. Therefore, Python and any other scripting language that has this way of variable creation is said to be dynamic typed or dynamically typed. Okay, now Python variables, and not just Python, almost all programming languages, variable names are case sensitive. So age equals to 12 and capital AGE equals to 13 are not the same thing. So you realize that if I type this, I get 13. If I type that, I get 12. So far as these names vary in any respect according to the case, and they are different. So we say that variable names are case sensitive. So always when you are writing your program, you have to remember that. Now, if you are coming from C++ background and Java, there is a tendency to think of variables as things that store objects. Yeah, in C++ and pretty much most languages, we declare variables as allocated memory space, which is quite true. But because everything is object in Python, thinking of variables as things that store objects isn't a very helpful one, but rather when you think of variables as labels, pointers, or references to objects which live somewhere in memory, it makes it very easy to understand these things. Okay, and multiple variables can actually point to the same object. So look at this, for instance. 2 in Python would be represented as an object. Is that okay? To be represented as an object. So if I do something like age1 equals to 2 and create another variable called age2 and assign it to 2, is that okay? Now I want us to check something. Python always assigns a unique identity to every object it creates, and that identity stays pretty much constant throughout the entire lifetime of the object in the program. Is that okay? And you can check the ID for any given object by using a predefined or an inbuilt function called the ID. Is that okay? So if I want to find the ID of the object 2 using its label, I can just do age1 and it returns this value. Now per the C Python implementation, this value actually represents the memory address. Is that okay? It represents the memory address of the object. Okay, now let us do the same for age 2. Now compare these two. You realize that these are the same numbers. So if this represent the memory location, then it means that age 2 and age 1 are pointing to the same object. Remember, so that is why it is not appropriate to think of variables as things that are storing objects. Now I'm sure if I should do this in C++, this will come up with different memory address, because in C++ variables are treated as things that store values. Okay, so they are all pointing to different spaces, but in Python the emphasis is on the object itself, which in this case is 2. So far as you are using the same value 2, if you assign any variable the value 2, it will point to this same memory location, or it will have this same ID. So let's create a variable, call it name, just to be fancy, and assign it 2. If we check the ID of name, it should point to the same memory location. So it is good that you think of variables as just labels or pointers. So far as that particular object has not changed, any variable that you assign that value or that object will point to, it won't create, it won't duplicate, it will just point to that same object. But if I should do h2 equals to 3, now if I do id h2, you realize that now the address or the id has changed, because now h2 is pointing to what? A different object. So please try to understand this dynamics. Okay, it will help you, it will help you a lot. Okay, now every object has a type. Every object has a type. Okay, and in Python there are certain built-in types. We have the numeric types. The numeric types are used to handle anything numbers. Okay, and we have integers for whole numbers or numbers without decimal points. We have float for real numbers, numbers that can have decimal point. Okay, and we have complex. We also have a way of showing complex numbers. Okay, so with these three numeric types, you can handle almost every form of number. They serve as the fundamental numeric data types. Okay, we shall look at them in details. Then we also have the Boolean types. Okay, the Boolean types, and these include true or false values. So take it as yes or no values. So anytime you are writing code and you need to do something like yes or no, true or false, then the data types that you need are Boolean data types. Then we have the sequence types. Now the sequence types are used to group items or organize items. They usually form a collection of items. Okay, so for instance, Q is a character, B is a character. On the keyboard, everything on your keyboard is pretty much a character. Okay, so assuming I want to spell my name Eric, then how am I going to handle that? Well, Python defines a data type called string, which represents sequence of characters. Is that okay? So ERIC, these are sequences of characters, and anytime you want to save, you want to deal with things that are in word statements and non-numeric stuff, chances are that you would be using the string type. So the sequence type, we have strings, we have list, and we have tuple. Okay, so all these types are used for aggregate or composite data. They are able to store many objects at a time. Is that okay? They're able to store many objects at a time. Now, Python defines a function called the type, which you can use to check the type of any object in memory. So for instance, if I create name equals to Eric, so for instance, if I create an object, or a variable pointing to the object Eric, okay, hit enter. If I want to know the type of this variable or this object, I can just type and realize that so it is a class and it's a string. Okay, the str represents a string. Now take note of this class. A class serves as the blueprint of an object. Is that okay? And pretty much like I said, in Python, everything you create is an object. So if I create age equals to 23, for instance, and do type, if I do type age, you see class what? Int. Is that okay? If I do something like balance equals to 5.8, which is a floating point number, and now I do type BAL, you see class what? Float. So everything is an object because the data types are all class definitions. Is that okay? You understand this better when we start with the concept of object-oriented programming. So that is how you display the type of a variable. That's how you display the type of a variable. Okay, so let's create a list. For instance, say names, okay, and a list is delimited by square bracket. Okay, so I have Eric, I have Hilda, I have Steve, and let's say Kezia. Okay, so you realize that here I'm creating, or I'm having multiple names, a list of names. Now if I want to do this with ordinary strings, it would be, or it will mean I have to create 4 different variables, one to store, one to reference Eric, one to reference Hilda, one to reference Steve, and another to reference Kezia. Okay, however, by using a list, I kind of get a container to keep all these values. So if I do types and I write names, it will tell me that it's what the data type is a list, and I can always access any object in this by specifying the name and the index. I will explain this in a later video. So you can see that by doing this I get what Eric. So the same way, if I want to access Hilda, I can just put 1 over here, and I will explain why the 0 and the 1 in a later video. Let us also create a tuple. So I could have done names equal to, tuples are delimited by parentheses. So Eric, Josie, Pearl. Okay, so we have this, and if I hit enter, now I type and pass it names, and it tells me that it is class what, tuple. So this is a very simple explanation of variables and objects. If you really want an in-depth understanding, I will urge you to check out the Python documentation, which has a great resource about Python. You can read more about it. All right, this is Professor, and thank you for watching. See you in the next video.